Molality is a little different. The word looks kind of the same, doesn't it? But it's a little bit different. And the reason for molality is sometimes if you have a situation in which the temperature may vary, right? Remember how we said temperature and volume are directly related? Remember that? So if we're using something that involves volume and the temperature increases, well, the volume may increase as well. You might encounter a density issue. Okay? Now, it's not very often, but every now and then it can happen. So because of that, we have this measure called molality. And you'll see the difference here. By the way, we use a small kind of a cursive looking M. Molality is equal to moles of solute. So that looks the same. But here's the difference. Per kilogram of solvent. Now, back over here, remember this guy right here? Solution equals solute plus solvent. Now we're only dealing with one aspect of the solution. Not both, just one, all right? So molarity, moles of solute per liters of solution, the whole thing. Molality, moles of solute, kilogram of solvent. All right? So let's say that we have this same setup over here. We're going to use 5.84 grams of NaCl again. And let's say that instead of giving us the amount of solution, I'm going to say that we have 120 grams of water. Okay? So I'm using 120 grams of water to dissolve this. Here, I'll give us a little box again. Do you like the boxes? Is that okay? Okay, all right. So grams of sodium chloride and grams of water, and we need to find the molality. All right? So we did this before. If you don't mind this, I'm going to refer you back to here, right? So we already know that we have 0.1 moles of NaCl. Now, the point here is if you have a mass, you're in Gramsberg, right? So if you're in Gramsberg, to go back to Molopolis, you have to divide by the molar mass. So it could have been anything, right? It could have been anything. So we're just using this for the sake of time, right? I don't want to keep you watching the video all day long. So here we go. 5.84 divided by 58.4 gives us 0.1 moles. So we know we have 0.100 moles of NaCl. Okay? So all that's left to do is to find the amount of kilograms of water we have. All right? Now, 120 grams. And how many grams are in a kilogram? No. 1,000. All right? I know. One or two of you probably said it, but people are probably wondering why you're talking to yourself. So 1 kilogram. 1 kilogram is equal to 1,000 grams. So we put it this way, grams cancels. 120 divided by 1,000, we get 0.120. Again, if you want a quick way of doing this, sort of like milliliters, right? We move the decimal 3 places to the left because it's a factor of 1,000, all right? So now, to find molality, we have moles of sodium chloride over, we've got kilograms now, kilograms of water. And in this case, oh goodness, let's see, that's like 0.8, I think it's 0.833 mole, it's kind of hard to say, moles per kilogram, molal, mole. Yeah, right. Moles per kilogram. Okay, so there we go. There's our answer. All right. One more. One more. And by the way, you can find all these in section 2. That's pages 480 through 488. All right? So 480 through 488. The last one we're going to talk about is called mole fraction. Mole fraction. Okay? Mole fraction. And we have this funky looking X, right? And let's say we have a mixture of two things. All right? And we'll call them A and B. So the mole fraction, the amount of mole fraction of A in that mixture would be equal to the number of moles of A, of compound A, divided by the number of moles of A plus, guess what, the number of moles of B. You see that okay? Yeah, probably so. If you blow it up full screen, yeah, you should be able to see that okay. Moles of A, moles of B. So, the mole fraction of B then would be moles of B divided by moles of A plus moles of B. All right? So let's try one of these. And let's say we have a solution of hydrochloric acid. All right? And it's 36% hydrochloric acid. 36%. You're like, percent? No, we're going to get moles from that, right? Remember way back when we used to do percent composition and solving for empirical formula with percent composition? What did we do when we encountered a percent? We just changed it to grams, didn't we? All right? So if we have a solution of hydrochloric acid that's 36%, that means that in 100 grams of it, 36 grams would be hydrogen chloride, and then the other 64 grams would be water. You get it? Sorry, hang on, my computer went to sleep. I'm back. Okay. I'm even boring my computer. Okay, so 36 grams of HCl, 64 grams of water. Now, what we have to do, as you can tell, we have to convert everything to moles here. So this, if we're going to find the molar mass, we're going to divide by the molar mass of hydrogen chloride. That's 1 plus 35.5, that's 36.5. I really should have made this 36.5%, shouldn't I? Oh well. Okay, so there's that. And 1 mole. And then down here, same thing. We're going to convert this to moles of water. Okay, 18 grams. That's our molar mass of water. How'd you get that? 1, okay, H2O. H2O. The molar mass of hydrogen is 1. I'm pointing, but you can't see the periodic table from where you are. Here. There we go. See, over there? Nope. There. 1 plus 16 is 2 1s and a 16. That's 18. And we're back. You dizzy? Whoa! All right. So I'm going to do it like this, give myself a little more room. I can creep over here a little bit. So now we've got basically 1. I'm gonna go ahead, I'll say 0.99. 0.99 moles. Okay. This one, let's see, 3 and that's 6. Something like that, 3.6 moles. Okay? 3.6 moles. So I figured out the number of moles of each one, right? Number of moles of each one. And now what I have to do is arrange it to find the mole fraction of each. I'm going to do it over here. Cool? So we're just going to do, I tell you what, the mole fraction of HCl. And I'll show you something that happens when we find the one. We can always find the other. All right, HCl. Moles of HCl, 0.99. Divided by, 0.99 plus 3.6. I really think that's probably like a 0 there or something like that. Pretty close anyway. All right, so we've got 0.99 divided by 4.59. Okay, 0.99. Can you see that okay? The glare, not too bad. 0.99 divided by 4.99. All right, so that's going to give us, and it's what we call dimensionless. Dimensionless. Simply put, there are no units involved with this, okay? No units for this. So the answer is just 0.22. 0.22. I'm going to call it 0.22. All right? Now, if I did the one for water, it would look like this. 3.60 divided by 0.99 plus 3.60. It gives me 3.60 divided by 4.59. And the answer is going to be, wow, 0.78. Man, how did I do that? Here's how. Mole, it's in the name, mole fraction. A fraction of what? A fraction of the whole. So these two together should always equal 1. Cool? Hey, one more thing. You mind? This is like a little bit extra here. One more thing, and then this is going to be all. Right? And that is something called the dilution equation. Not elution. Those are people from far away. Dilution equation. If I had, say, a jar of concentrated hydrochloric acid. So let's say I had a jar of hydrochloric acid, okay, and I didn't want to, just have a bunch of different concentrations. I just wanted to have, one concentrated jar and then make it as I go along. Seems reasonable, right? Well, let's say I've got 10 molar HCl. 10 molar HCl. In every liter, I have 10 moles of hydrogen chloride dissolved into that, right? That's 365 grams dissolved into 1 liter. It's almost, it's not quite a pound. It's like 3/4 of a pound of hydrogen chloride mixed into this liter of water. All right. Anyway, it's a very simple equation. The molarity originally, all right, times the volume originally is equal to the final molarity times the final volume. All right? So let's say that I wanted to make 100 milliliters of 2 molar hydrochloric acid. All right? My end game is 100 milliliters. Right? Here, let me do it over here so you can see it a little better. That's my V2. My end game on concentration is right here. That's my M2. So what's my original concentration? Right here, M1. Right? So the question would be, how much of the concentrated stuff do I need to use and dilute that with water until I get 100 milliliters? So M1 times V1 equals M2 times V2. So 10 times V1 equals 2 times 100. Okay? So that's 200, right? V1 is equal to 200 divided by 10, right? Or 20 milliliters. Pretty easy, right? So in other words, if I have a concentrated amount, but I want to make a solution that's 100 milliliters with only 2 molar HCl, that means I'm going to use 20 milliliters of HCl, concentrated HCl, and mix with that, how much water? 80 milliliters. Okay? So I'll mix 80 milliliters of water with that and get my 100 milliliters of solution. Cool? That's kind of sloppy, but does it make sense? I hope it makes sense. If it doesn't, you can email me or go back over this one more time and see if you pick it up. Okay? If not, let me know. Be happy to do some one-on-one with you or whatever it takes. All right, guys, it's a lot today, but I appreciate your time. Have a great day, and God bless you.